Hi everyone, I'm James. My teammates are Joseph and Anshul, and today we'll be introducing our stock recommender system for personalized stock investing. For instance, if you're interested in the up and coming healthcare tech companies, back in 2017, there were over 70. Alternatively, if you're looking into the up and coming self-driving car companies, back in 2017, there were over 260. And one of the big problems that is happening in industry right now is more companies are letting go of their pension plans, and so some people end up retiring from their jobs without that retirement savings. And so we'd like to encourage, through using our stock recommender system, ways that they can start investing the money while they're making it. And now Joseph will dive into introducing a bit more on the background of stock, as well as the problems that financial advisors face and how we can leverage AI to help them.
Hey everyone, so there's no shortage of advice when it comes to buying and selling securities. There are resources online, journal articles, news articles. You can go to professional advisors and pay a fee. You can consult different firms. You can also go to TikTok, which is a popular form of media nowadays, Instagram Reels, YouTube videos, which is another very popular form of getting your information. Uh, but our idea here is to provide a recommender system that aggregates data from the largest stock exchange, which is NASDAQ, up until 2000, and make choosing your securities easier. Right. And our recommender system is largely based off of these three things at the bottom here: deviation theorem, which is with respect to the stock price average across some number of days, use it as a technical indicator. Another one is similarity vector. So with respect to companies, obtain top similar companies with between each other. And also take into account the financial status of a company and other metadata as well. Slide, please. Okay, so there are a lot of different problems and problem areas. One is the complexity of investment decisions. It's very complex when you have to deal with all this data from different sources, like company data, um, any trend analysis that you might do with prices, um, like any other statistical modeling that you're dealing with. Like a lot of these systems are very complex, and it's difficult for the everyday investor to use. Where you just need a decision on whether or not you want to buy or sell a fund or a ETF. And there's also a lot of information out there, as I mentioned earlier, coming from different sources and varying levels of complexity. Um, you can you can be looking at data as simple as just the price of when it closed, or the highest it is, or the lowest it is on a given day. You can also have data that is dependent on like trends. And there's just a lot of information out there. Um, Market volatility and risk management. The market is ever changing, and it's very difficult to figure out, like for example, like when a recession is going to occur, or when we'll have a bull run, or a um, or heading towards some kind of depression, or also risk management, the idea that each person has their own level of risk that they're willing to accept. There's also diverse investment preferences of each user, with regards to industry, with regards to their interest in a given space, like just depending on like their kind of personal preference there. Real-time insights. So the idea that you're trying to get as accurate as information and up to date as information that you can. But you might not actually get that because you don't know where to look, or this data is not readily available to you. Next slide, please. Okay, and data quality and interpretation, the idea that your data like might be noisy. How clean is it really, right? That's a big problem in the data mining space. Um, and preparing data. right? Scaling your data. So you might have to transform your data, right? Like the interpretation of that data is really important when it comes to training models. And another couple bullets here: user experience and transparency. The idea that although you've gotten data from a specific source, how transparent are they about how like they compile that data? Even when it's displayed to the user, like what did they do to that data in order to kind of train the model that they're using to make the decision? User experience, of course, like if you have a website that is very difficult to interpret, um, it might be counterintuitive when it comes to buying and selling the securities for the user. Evaluation and performance tracking, how well is the recommender system actually doing, right, when they recommend you these securities? This is another big issue, and somehow gathering metrics on the performance can be very difficult. Yeah, just highlighting all these key challenges that is that different advisors and automated systems are trying to find solutions for, and there isn't a silver bullet to this. Slide, please. And for data side exploration, I'm going to go ahead and hand it over to Anshul.
Okay, so for a data set, we use the NASDAQ stock market index data set from the Yahoo Finance, which is about 2.75 gigs in size. And we think that this much of data is a strong foundation for the initial part of our system design. Now, the data set consists of about 5,800 individual stocks and about 2,100 EFTs. So with this, like, we will be able to like perform predictions theoretically for pretty much all of them. And with this 2.75 gigabytes of data, and it's divided into like individual stocks, that with that we again assume like we have definitely sufficient data for our system design. Next slide, please. So for the data pre-processing steps, there were several steps that was performed. Obviously, we imported the NASDAQ stock data set into a data frame that this will enable us to use it in our code base. And then we also included the external symbol metadata, such as company stock ticker and financial status information. This will ensure like the predictions are not only made on the closing prices and the price returns, but instead they're also made on some external factor data. And on the data set, a sliding window approach was taken to create sequences of closing prices. In the graph, you can see the red line. That's the smoothed out curves or the data points, which is this is happening after like taking a moving average of 100 days in the data set. Excuse me. You can see in the actual data set, there's a lot of tiny variations. But when you take the 100 days moving average, it smooths out. So it's easier for the model actually to be able to train and find patterns in the data. Finally, the data set we use min-max scaler to like normalize the scale. Next slide, please.
And now we'll be talking about our time series deep learning solutions approaches. Starting, we worked with PyTorch and created a baseline LSTM neural network. So LSTMs provide a flexible architecture working with multiple LSTM layers, dropout layers, preludes, and so forth. And the LSTMs are also known for being good at capturing complex patterns, working with multiple input time steps to predict future stock prices. With those stock price predictions, we can help stakeholders, the financial advisors, by providing them with the additional future information that help them to make investment decisions, ultimately helping their stakeholders or their customers they're working with. LSTMs are also pretty good at adapting to the changing conditions within the stock market. Again, we're just leveraging at least one LSTM layer with a 20 to 30% dropout, and that is for helping our model to generalize well. And then we evaluated based on MSE, RMSE, and F1 score. Now, Anshul will talk about the advanced TensorFlow transformer approach we took.
Okay, so for my approach, I use the transformer neural network, and I use this approach because transformers are known to like effectively capture the long-term dependencies in the data. And now let's see how it's done. So initially we have the time to vector layer. So in the data set, we have the time data, and it cannot be used directly in a neural network. So we need to convert it into numerical vectors. And after that, the model also uses single and multi-headed self-attention mechanism, and that's to discover any dependencies within the data. And after that, it's just your regular global average pooling, dense and dropout layers that will just ensure that the most relevant features are used in the predictions. And finally, the model was evaluated using MSE, MAE, and mean absolute percentage error.
And here are our architectures to visualize what we're talking about. So in the case of the LSTM PyTorch network, we had utilized our data preprocessing pipeline, creating features through a sliding window of the past 100 days. For instance, earlier we saw the graph that showed the moving average of 100 days compared with our stock closing prices. And we found that it had a nice smooth curve following that stock close price trend. And so we wanted to do a similar thing for the features. And then we have associating stock final closing price labels. And so we take these features, we feed our LSTM neural network with them to train it. We utilize one input channel because we're just using one set of features. And then the LSTM learns that time series stock close price data. For the predictions, we drop out about 20 to 30% to help it generalize well. And then we utilize one alpha channel to predict the final closing price. And we evaluate our prediction with the label using our loss metrics such as MSE or MSC. And we also, to see how well the model is learning, we evaluate with the F1 score to see how well the model is performing. And now Anshul will talk about his transformer architecture.
So on the right, you can see the model architecture for my transformer approach. And at the top, you can see the input dimension is none 128.6. And the 6 is because we had 6 features available in the data set. So in the second block, you can see the time to vector layer, and that is to like convert the time data into numerical embeddings, which further can be used in the network, which shown below. And then we in block 4 and 5, we have the 2 attention layers that is used to capture dependencies in the data. And after that, we simply have the global average, dropout, and dense layers. And at the end, it will just give us a prediction based on it's actually calculated based on the average returns for the day, which is like the current value minus the value before or the value that was invested. But it can be like the final closing price can be actually calculated using that return value.
And now we'll go into the metrics. So in the case of the LSTM, we can see quantitative metric graphs. On the left, we have RMSE for train and validation. Training, it was below 0.05. Validation started at 0.30 and it went down close to 0.05. In the case of the F1 average score, for training, it was slightly below 0.15. And then for validation, it was between 0.50 and 0.4. And that again is across 10 epochs of training. F1 score, as we'll see, was very important because it helped our model to predict well, generalize better when it came to switching between the validation to the testing set, predicting the stock closing prices, similar to the ground truth trend that's happening. So on the left, we see the validation set. There's a lot of the LSTM neural network is trying to fit as close as possible with the predicted line as to the ground truth line. So there might be some overfitting that's happening, but for this baseline, it's pretty good results, because what we see in the testing set is that the model is able to predict along a similar trend to the ground truth price. And now Anshul will go into the transformer results.
Okay, so this is a qualitative metrics average model loss graph for my transformer, and you can see over here the blue line is the training loss, and at around one epoch, after the epoch one, the line is pretty much straight, and the validation loss is also at its lowest at epoch one. So this would usually mean like the model is overfitting, or we have less data, or but actually, next slide, please. If we look over here, the line actually is kind of like a smooth out curve. It doesn't exactly follow the actual data. So with this, we can say the model is not entirely overfitting, but it definitely is to an extent. But if you look at the validation data, and this is, mind you, the closing returns, not the price. Like I said, mentioned before, the actual price predictions can actually be calculated afterwards. So if you look at the range, it ranges from 0.6 to 1.4, and this is quite a small range. So if we keep that in mind and like look at the predicted lines by the model, it actually kind of follows the curve of the actual data points. So with this, we can assume like the model it's not perfect, it's not the best, but it's definitely performing good, I would say.
Thank you, Anshul.
Next, yeah.
And now Joseph will talk about how we integrated everything with the predictions, and then utilize them to compute the technical indicators for the recommender system.
Yeah, everyone. Right. So as James mentioned, we leveraged a variety of technical indicators to essentially make the decision of whether or not to buy or sell. That's the final output here. It's either a true or false value, buy or sell. We've divided it to multiple different features or columns here. We have, based on James' approach and Anshul's approach that they've mentioned, separate column decision makers in different columns with respect to the moving average convergence decision, the golden cross decision, relative strength index, and another column for financial status decision. So if you can imagine, all of these columns are essentially uh, showing that like whether or not they are based on the predicted price of the closing price, whether or not the security should be bought or sold. And we make certain combinations between these in order to make a final decision. Next slide, please. Right. So in conclusion, out of common interest in financial forecasting, we got together and created a stock recommender system. We used H2O Wave with the open source AI framework, which allowed us to make dynamic like widgets and other UI components very quickly. We chose to use MySQL and SQL Alchemy for our data layer and interacting with that. And we faced a lot of challenges regarding scope creep and lack of time and a lot of hardships during the semester. So we were unable to completely build out all the features that we wanted. But I think that we have a good MVP on the H2O Wave app. Yeah, like I mentioned, we have a lot of different pages that we wanted to build in order to train the model, deploy the model all through the H2O Wave app. But again, like because of time constraints, we weren't able to get that working. Yeah, we were processing hundreds of stocks and ETFs. So we were only really bootstrapping our app by generating our CSVs on a Kaggle notebook, and then writing using a script to essentially seed the database and work with it in the H2O Wave app. Next slide, please. So here's a quick recorded demo of our app. Again, this is just a minimum product. We have the main page, which shows the recommended stocks of what you should buy and sell. I believe these are just the markup or UI cards added from the main page endpoint of our H2 Wave app. Build off the SQL Alchemy query that interacts with MySQL. What we're doing here is aggregating the amount of like in terms of decisions of different columns based off the technical indicators that we mentioned earlier. And this is the graph of all of the predicted closing prices that eventually make that decision. So you can see like the different technical indicators in their respective graph. And as a future work, like we'd like to add the ability to train and deploy the model all within the H2O Wave app. So that would be like a good thing to incorporate in. And that would be it for our demo, I believe.
Thank you, Joseph.
Yep.
Yeah, to elaborate a little further on that, right now we train our models from Jupyter Notebook. We end up performing the predictions, computing the technical indicators, getting the recommender system results, and filling up our MySQL database's tables with those results. So our two other features we'd like to work on, the train and deploy model, would allow the user to get the latest stock data from Yahoo Finance, NASDAQ, and then train the model based on the latest data, getting an updated model, and then deploying the model and getting more latest for prediction results, going for a bit closer to a real-time experience that my colleague Joseph talked about earlier, being one of the problems we face, financial advisors face in stock investment advising. Thank you.
Thanks, everyone.